This cockpit review tape is intended to refresh your memory concerning the nomenclature and normal operation of switches, lights, and indicators on the second officer's panel. It is based on information available as of January 1981 and is for training purposes only, as it may not be current. You may want to stop the tape and get the panel fold out from the back of your training manual. We'll start at the lower left of the panel and cover it in the same order as the scan pattern followed by the second officer. First, the cabin pressure auto manual selector. In auto, pressurization is controlled by the auto, semi-auto, or standby modes. We'll talk about these modes a little later when we come to their controls. In manual, the outflow valve is locked in position, but can be moved by pushing in and rotating the manual control wheel in the appropriate direction. The manual control wheel is connected to the outflow valve by a cable and follows valve movement in all modes of operation other than manual. An indicator just to the right of the control wheel shows the position of the outflow valve. Moving to the right to the hydraulic system, the instruments at the bottom of the panel indicate the temperature of the fluid in the reservoir. The normal operating range is anywhere below the yellow band. At altitude, in cruise, a reading as low as 0 would be considered as normal. On the quantity indicator is a chevron just below the 4-gallon mark. If the fluid drops to this level, the system should be serviced. Quantity is measured with full system pressure. The aux hydraulic pump switches are momentary contact in either the start or stop positions. Both pumps furnish pressure to hydraulic system number 3, and both pumps are powered from the AC ground service bus. Aux pump number 1 can also be powered from the air-driven generator. Both pumps can be turned on or off simultaneously by a switch on the forward overhead panel. The left engine-driven hydraulic pumps have conventional on-off switches, which control their output. The right engine-driven pumps have auto on-off switches. The normal configuration is on-auto. That is, all switches in the up position. The off selection feathers the pumps so that they do not pressurize the system, even though turning. The auto position keeps the right pumps feathered in reserve unless a pressure loss is sensed from the left pump. Each pump output is monitored by a temperature high light and a pressure low light. The pressure low lights are on whenever the selector switch is on and pressure output is low. In the auto position of the right pumps, the pressure low lights are off unless the pump pressure is low when the pump is on demand. The 3 hydraulic systems are normally isolated from each other. However, in the event of engine-driven pump failure in any system, provided that fluid quantity above 1 gallon is available, pressure can be restored through one of 2 backup systems called reversible motor pumps. These motor pumps are controlled by the 1-3 and 2-3 pump switches just below the pressure gauges. Hydraulic pressure from either System 1 or System 3 will operate the 1-3 pump and pressurize the opposite system if necessary. The 2-3 pump connects Systems 2 and 3 in the same manner. Remember that these pumps are reversible and that fluid is required to be in both systems as no fluid transfer takes place. When the 1-3 and 2-3 pump switches are off, electrically controlled valves on both sides of each of the motor pumps are closed. With the switches in the armed position, the valves are normally closed, but will open when any engine N2 RPM drops below 45%, so that hydraulic pressure will not be lost. In the on position of the switches, the valves are open. Whenever these electrical valves are open, differential pressure will result in pump operation. Loss of hydraulic quantity to below 1 gallon in a system will close the control valves to the associated motor pump. If a stall warning occurs below 250 knots indicated airspeed, extending the outboard slats, the control valves will open, with the switches in the arm or off position, provided the fluid level is above 1 gallon. The valves will be closed regardless of switch position if the air-driven generator is deployed and its selector switch on the overhead panel is in the hydraulic position. The ADG aux pump is not capable of operating more than one hydraulic system satisfactorily. The rudder standby switch between quantity gauges 1 and 2 controls 2 similar motor pumps to back up rudder and stabilizer trim operation. However, these rudder standby pumps are not reversible. One supplies the lower rudder with pressure from hydraulic system number 3 when system number 2 has been lost, and the other supplies the upper rudder and the stabilizer trim from system number 2 when the normal system number 1 has been lost. In addition to being non-reversible, there is another major difference between these pumps and the 1-3 and 2-3 motor pumps. Hydraulic fluid can be lost from the main number 1 hydraulic system, and the rudder standby system will continue to operate the upper rudder and stabilizer trim, as it has its own supply of fluid trapped on the pump side. The same is true of the lower rudder standby pump. With the switch in arm, both rudder standby electrically powered supply valves are open. The pumps are prevented from operating as long as normal hydraulic pressure is available, but will run at any time the pressure drops on the pump side. The rudder standby power off light is out whenever both electric supply valves are open. The valves close with the switch in the off position, and either valve will be closed by a float switch if the trapped supply of fluid is lost. If this happens, the power off light will come on. The hydraulic pressure gauges read hydraulic pressure only, not accumulator pressure. The systems are operative if pressure is above the red band. The first thing we come to on the electrical system are the CSD oil pressure low lights and disconnect switches under safety covers. Pushing a disconnect switch for 3 seconds will disconnect the associated CSD, which cannot be reconnected in flight. Disconnect can be confirmed by the CSD oil pressure low light, a generator off light, 0 AC load, and no indication of voltage or frequency. The CSD oil temperature indicator normally reads outlet temperature on the outer scale. Rise temperature may be read on the inner scale by pushing the Push for Rise button. Either temperature in the yellow band calls for an irregular procedure. The generator fail lights, just above, can come on as an indication of an electrical or mechanical problem, and may be reset by a button on the upper main circuit breaker panel. The generator can operate normally even though the light is on. It does not disconnect the generator from its bus. If the light cannot be turned off, the generator must be disconnected. The generator off light does indicate that the generator is not connected to its bus. Generator switches are normally left in the on position. This allows any generator relay to connect its generator to the appropriate bus if the generator is operating normally. With the generator operating normally, the associated generator off lights will be off and the load meter will indicate above 0. An engine generator will automatically displace any other power source on its bus. In the off position, the generator relay is open and the generator is disconnected from its bus. The reset position is used to reset the generator field when it has been deactivated by a fault or by moving the engine fire handle to the generator field disconnect position. The parallel generators button activates the auto paralleling feature. Generators will parallel only with another engine generator. There are no manual adjustments for paralleling. The AC load meters indicate the load on engine generators only. They should never exceed 1.5 and should not exceed 1.0 for more than 5 minutes. The left emergency AC bus off light is on when the bus is not powered. The bus is normally powered from the number 1 generator bus and alternately from the battery direct bus through an inverter by placing the emergency power switch to on. The battery will then furnish power to the captain's instruments and radios, plus the N1, N2, and EGT indicators for up to 30 minutes, with the exception of the number 2 and number 3 engine N1 instruments on airplanes 38 and subsequent. The battery charger is disconnected when the emergency power switch is on. The blue dual land selected light comes on when the second autopilot is engaged for auto landing, and the green dual land power on light will be on when the buses are isolated for dual land. The right emergency AC bus off light is on when the bus is not powered. The bus is normally powered from generator bus number 3, but can be powered by the air-driven generator. The right emergency bus furnishes power to the first officer's instruments and the number 2 radios. The AC bus off lights are on when the AC buses are not powered. If the associated generator bus is still powered, check the AC feed circuit breakers on the generator bus, which is near the top of the upper main circuit breaker panel. The blue AC bus tie isolate lights should all be on when the generators are disconnected from the tie bus as a result of dual land mode selection. The amber AC bus tie isolate lights indicate that the respective generator bus is not connected to the tie bus. If the tie relay senses a bus fault, it will lock open and the isolate light will come on. An electrical system reset switch at the top of the main circuit breaker panel can be used one time to the up-release position to reset the relay. Either the generator relay or the bus tie relay can be locked open if relay chatter occurs. Whenever this happens, the affected relay can be reset by placing the electrical reset switch momentarily to the down position. The tie bus can be powered by normal external power or by any generator bus, except when that bus is being powered by the APU. The normal position of the AC bus tie switches permits automatic control of the tie relays between the AC tie bus and the generator buses. With a tie switch in the isolate position, the affected generator bus cannot be connected to the tie bus. The external power available light is on whenever usable external power is plugged in. The external power switch can connect external power to the tie bus when the power available light is on. It is then held on electrically as long as the external power available light remains on. External power, when selected, will power the AC tie bus and isolate any generator bus which may have been powering it. When external power is connected to the tie bus, the blue external power in use light comes on whether or not the tie is supplying any generator buses. The white emergency power in use light comes on whenever the emergency power switch is on and the battery is supplying the left emergency AC and DC buses. When the battery is used for emergency power, the charger is disconnected and the battery is not being charged. The power sources for the transformer rectifiers are as follows. Number 1, directly from generator bus number 1. Number 2A, directly from generator bus number 2. Number 2B is connected to the ground service bus, which is not shown on the panel. And number 3 gets its power from the right emergency bus. This arrangement makes DC power available to the ground service system when the main buses are not powered. Remember that the ground service bus can be powered directly from external power or the APU generator, but that it automatically connects to generator bus number 2 whenever that bus is powered from any source. On airplanes 38 and subsequent, there is a DC ground service bus off light on the second officer's annunciator panel, which indicates that the DC ground service bus is not being powered. Also on these models is a DC ground service bus power switch located on the second officer's equipment panel, which can switch power for the DC ground service bus from the normal source, which is TR2B, to an alternate source, which is TR2A. Switching power sources should turn off the DC ground service bus power off light. Having number 3 TR connected to the right emergency AC bus makes emergency DC power available whether the system is powered from generator bus number 3 or from the air-driven generator. DC load meters show loads on the 4 TRs. 1.0 on the load meter is the normal rated capacity. TR number 1 powers DC bus 1 and the left emergency DC bus. TR2A supplies DC bus 2 and the left half of the DC tie. TR2B provides DC ground service, not shown, and the right half of the DC tie. Number 3 TR is connected to DC bus 3 and the right emergency bus. The tie relay switches open or close the DC tie relays. Unlike the AC ties, these relays are not automatic. They are normally left open as there is no provision for sharing loads. DC loads are rarely equal, and one TR may take the whole load. An off light is provided for each DC bus. If a TR is inoperative, the appropriate tie relay can be closed to power its DC buses from another TR through the left or right DC tie. Number 2 DC bus and the ground service DC bus have load-shedding relays, which prevent them from being powered anytime the associated AC bus is dead. The left emergency AC and DC buses can be powered from the battery, and the right emergency buses can be operated from the air-driven generator. When the air-driven generator is used to supply the right emergency buses, DC bus 3 is isolated from the TR3 output. It can be supplied from the DC tie if there is another available TR. The battery switch locks in the back position by rotating the switch in a clockwise direction to align the white line with the schematic. When the battery switch is in the off position, the battery is connected only to the battery direct bus. The clocks run, the fire bottle discharge circuits are available, and refueling can be accomplished. With no other power on the airplane, placing the battery switch to the BAT position powers the battery bus from the battery. The battery bus circuits are now operable, including the fire detectors. When power is applied to all of the aircraft buses, the battery is automatically isolated from the battery bus and is connected to the charger. It remains on standby to power the battery bus if the normal sources should fail. Normally, TRs 2A and 2B power the two halves of the DC tie and the battery bus. TR1 or 3 may be used for the battery bus through the DC tie by closing DC tie relay 1 or 3. Loss of power on the battery bus causes the battery bus off light to come on if the battery switch is on. Now, let's look at the controls and indicators for the APU. Just above the battery switch is the APU control system switch. It selects the normal or standby modes of operation. In normal, N2 is regulated to 100%, which provides frequency control for the APU generator. N1 RPM varies in the white band, so as to furnish pneumatic air as necessary. It is regulated to 97% plus or minus 2% by variable stator vanes in the turbine section whenever engine ignition is selected to start A or B, to provide additional air for engine start. An APU fuel pump switch is provided which uses battery power to run a fuel pump for the APU if AC power is not available. The APU master switch is a 3-position switch with off, spring-loaded start, and run positions. A blue standby on light is a reminder when standby has been selected. Amber oil pressure low, oil temperature high, and fuel pressure low lights monitor operation. N1, N2, and EGT instruments are also on this panel. At top right is an oil quantity instrument for the APU, and a fire control panel is located just below it. The fire panel has a red APU fire light, an APU off agent arm switch, and 2 cylinder discharge switches. Remember, these cylinders are also used for the number 2 engine. Whenever one of the N1, N2, or EGT instruments exceeds the red line or has a loss of signal, the APU will shut down automatically. It will also shut down if a fire warning light comes on, or either the oil pressure low or oil temperature high amber warning lights come on. If the low oil pressure circuitry is out, attempting to start the APU will result in a flashing low oil pressure light. This will prevent the APU from starting until repaired. The automatic shutdown feature is also operative in the standby mode. The APU fire warning light may also come on if a number 2 engine pneumatic duct leak occurs in the APU area. Standby operation requires monitoring, as the control of RPM and temperature is not as refined. 4 quarts is the minimum quantity of oil for starting the APU. However, you may not be able to read the instrument if electrical power is not on the buses. In this case, the APU may be started and the oil quantity checked when power is established. When the APU is running, the oil quantity must be above a 0 indication on the gauge. After power is on the buses, a number 2 tank pump should be used for APU operation. To the left are the APU generator controls. The load meter, generator off light, and reset switch are similar to the main generators. When the generator output is satisfactory for use, the generator off light will be off and the green power available light will be on. If the off light remains on, either a malfunction has occurred or the APU off agent arm switch has been activated. In either case, the reset switch may close the field and restore normal operation. The amber fail light monitors electrical circuitry within the generator and mechanical failure as well. If this light comes on, it may be reset by the same fail reset button on the upper main circuit breaker panel that is used for the main generators. If the light will not reset, the APU must be shut down. The generator bus on-off switches make the APU generator output available to the main generator buses when on. Switching is automatic as main generators become available or are shut down. The 3 blue power in use lights indicate that the APU generator is powering the particular bus. To ensure proper cooling, a 90-second forced idle timer starts as the APU is unloaded pneumatically with the APU isolation valve switch. If the master switch is placed to off before the cool down period is ended, shutdown is delayed. A volt-amp frequency selector switch permits you to read voltage and frequency from the various electrical power sources. On the AC volt and frequency instruments just above the switch, the condition of external and galley external power, the APU generator, each engine generator, the air-driven generator, or the left emergency AC bus can be read. When an engine generator is selected, the DC voltmeter reads voltage for the associated DC bus. In battery and left emergency bus, battery voltage can be read, and on the ammeter, the charge or discharge condition of the battery can be monitored. Battery and left emergency bus is the normal selection. The galley may be powered from an external power source separate from main external power, or by the generator buses when they are powered from an APU or engine generator, but not by main external power. The coffee bar may be powered from generator bus 3, no matter what its power source, but cannot be powered from galley external power. A single generator may be overloaded with galley power and normal power on at the same time. If any generator senses an overload, the galley buses and coffee bar will be disconnected and the galley power off lights will come on. An electrical fault on a galley bus can also cause that bus to trip off. In either case, the reset position of the galley power switches allows the galley bus or buses to be reconnected to the appropriate generator bus. The galley overheat light warns of an overheat condition in the galley, and a ground warning horn near the left wheel well will sound. The horn reset position of the switch silences the ground warning horn. The test position of the switch tests the overheat light and the master caution and electric cue light, but does not cause the warning horn to sound. The next system on the normal pattern is the fuel system. At the bottom of the panel are the fuel schedule lights. First, let's talk about the normal fuel schedule. Tanks 1 and 3 have an inboard and an outboard compartment. Fuel for these tanks enters the outboard compartment and is taken from the inboard compartment. For structural reasons, the 5,500 pounds of fuel which fills the outboard compartment remains there until the inboard compartment quantity decreases to 5,500 pounds, and then the fuel in the outboard part of the tank drains by gravity into the inboard compartment. It is possible that the outboard fuel could start draining prematurely into the inboard compartment, or that when the inboard fuel quantity decreases below 5,500 pounds, the outboard fails to drain. In either case, the fuel schedule light would come on to alert you to the condition. There is an irregular procedure to cover either case. Certain combinations of low fuel and nose-high attitudes may cause the light to come on for as long as 2 minutes. The fill valve switches permit fuel to flow from the manifold into the outboard compartments of tanks 1 and 3 and into number 2 tank when the manifold is pressurized. With fuel loads in excess of 120,000 pounds, when number 2 tank contains more than 40,000 pounds, number 1 and number 3 fill valve switches will be held open magnetically for fuel management. With the manifold pressurized by number 2 transfer pump, fuel from tank 2 will replenish tanks 1 and 3 as burnout provides space. When all 3 tanks are approximately equal at 40,000 pounds, the 1 and 3 fill valve switches drop to off automatically. If fuel transfer is required when tank 2 is below 40,000 pounds, the fill valve switches must be held in the open position. The fuel quantity instruments read in 100-pound increments and are powered from either a main or an alternate source. If the primary power source fails, the fuel quantity indicator power switch above the main circuit breaker panel may be moved to the alternate position. An alternate indicating system computer can also be selected under the second officer's table in the event that all indicators fail. There is no correction possible for loss of a single quantity gauge. The tank pump switches control electric fuel pumps in the respective tanks. When a switch is turned on, the pump is activated, and the associated tank pump pressure low light is armed. The transfer pumps operate in the same way, except that they deliver fuel directly to the fuel manifold. The number 2 left-aft pump is powered by the right emergency AC bus to ensure a tank pump for number 2 engine in case of normal electrical system failure. Number 2 engine will not run without a booster pump. Again, regarding the fuel pressure low lights, they are only armed when the associated pump switch is on. The cross-feed switches control valves which connect the fuel manifold to the engine inlet lines, allowing any tank to feed any engine. If the valve position is not in agreement with the switch position, the cross-feed disagree light will be on. The fuel pressure instruments indicate a combination of fuel pressure from the tank pumps and the engine first stage pump. The fuel used reset button will reset the fuel used indicators to 0 when held in. The fuel used indicators show total fuel consumed by each engine since the indicators were last reset. They compute fuel used from the fuel flow meters and are not dependent on the quantity indicators. To the right at the cross-feed controls is the fuel dump switch. It controls a dump valve in the trailing edge of each wing to dump fuel from the manifold. If either valve does not open when the dump switch is placed to open, its associated open light will not come on. Moving the switch to open also closes all fill valves if open. The undumpable level is 39,900 pounds. When the first tank reaches its undumpable level, all cross-feed valves close. This causes the disagree lights to come on as the switches do not move, and the transfer pump in that tank shuts off, indicated by its low pressure light coming on. Then, as each of the other two tanks reach the undumpable level, their transfer pump low pressure lights will also come on as the pumps stop running. Again, the switches do not move. Moving the dump switch to close closes both dump valves and returns control of the fill valves, cross-feed valves, and transfer pumps to their own switches. When dumping to the low-level shutoff, monitor the system closely, as an electrical failure could permit dumping to continue below this level. At this time, please turn the tape over. The information on this tape is for training purposes only and may not be current. The fuel temperature indicator indicates the temperature of the fuel in the outboard compartment of the number 3 tank in degrees Celsius. On the total fuel quantity and gross weight indicator, the zero fuel weight is initially set by pushing in and rotating the ZFW knob. When the knob is released, the zero fuel weight and the fuel quantity add up to indicate current gross weight. As fuel is used, it continuously decreases to indicate current gross weight of the airplane. When the fuel quantity test button is depressed, the individual indicators go to 99,900. The totalizer indicates 299,600, and the gross weight indications increase. The two manifold drain and outboard fill valve switches, tank 1 and tank 3, are used together to vent the manifold from the outboard part of the number 1 and number 3 tanks. This breaks the vacuum, permitting the approximately 400 pounds to drain into the number 2 tank as its level reaches 2,000 pounds. The switches can be individually used in the event that an outboard fill valve is inoperative and fuel transfer to that tank is necessary. Just to the right of the totalizer are fuel filter pressure drop lights for each system. A light on indicates a pressure differential across the filter due to clogging. If the filter does clog, it will bypass, so the only procedure is to keep an eye on the fuel pressure. To complete the discussion of the fuel system, let's review some of the more important limitations. First, remember that operationally, we keep 2 pumps on for the number 2 engine, so that in the event of a pump failure, the engine does not quit. Number 2 engine will not run without at least 1 pump. Also remember that the maximum differential between the outboard tanks is 4,000 pounds. Another limit to be aware of is the fuel tank temperature of minus 36 degrees Celsius, and if remaining cruise flight time is more than 1/2 hour, change to a warmer altitude. If the fuel temperature indicator is inoperative, assume that the total air temperature indicator shows fuel tank temperature. It may be possible to increase fuel temperature by transferring fuel from the inboard compartment of tanks 1 and 3 to the outboard compartments. The fuel dump rate is about 5,000 pounds per minute, and undumpable fuel is 39,900 pounds. 13,000 pounds in each outboard tank, and 13,900 pounds in number 2 tank. The pneumatic system is used to supply compressed air for air conditioning, pressurization, wing anti-ice, cargo compartment heating, galley and lavatory ventilation, drinking water system pressure, and engine starting. Pressure for the pneumatic system can be supplied by the engines, APU, or an external source. The APU supplies air through system number 2, and external connections are available for systems 1 and 2. The first control we come to is the engine bleed air switch, which is normally placed to auto after engine start to allow automatic selection of either high or low pressure bleed air according to system demands. Normally, low pressure air will supply all system demands except during low thrust conditions. In off, bleed air is not available. In low, the high stage bleed is off. In high, there is automatic selection between high and low stage bleed, but at higher parameters than in auto. The switch must be pulled out to select high. High is automatically selected when the wing anti-ice switch is on. Without normal electrical power, low-pressure air is available regardless of switch position. The manifold fail lights indicate bleed air leakage outside the manifold, or high airflow to the outer wing from ducts 1 and 3. The forward parts of the number 1 and number 2 system manifolds are close together, and a failure of either manifold in this area will cause the lights for both systems to come on. Also, all 3 systems go through the center accessory compartment, and all 3 lights could come on if a leak developed there. The temperature highlights come on to indicate excessive temperature inside the manifold. The temperature highlights are inoperative when the APU isolation valve is in the open position or the bleed air switch is in off or low. The high stage open light lights up green whenever the high stage valve is open for any reason. The temperature of the bleed air from the associated engine and number 2 indicator will also show the temperature of the APU bleed air when in use. The APU isolation valve switch controls APU bleed air to the number 2 pneumatic system through operation of the APU isolation valve. When the 1-2 and 1-3 isolation valve switches are in normal, placing the APU isolation valve to the open position will cause the 1-2 and 1-3 valves to open, thereby pressurizing all systems. The pressure indicators will indicate pressure in the pneumatic systems regardless of the pressure source. As already stated, the 1-2 and 1-3 isolation valve switches in normal allow the associated valves to be controlled by the APU isolation valve switch. The open and closed positions permit operation independently regardless of the APU isolation valve switch. The isolation valve disagree lights are on when the respective valve does not agree with the position called for by the controlling switch. The wing anti-ice switch in the on position will open the wing anti-ice valves in the air to supply bleed air from systems 1 and 3 to provide ice protection to the outboard wing slats. The inboard slats are not anti-iced. The number 3 system also supplies hot air to the upper VHF antenna, but the valve is controlled by the number 2 engine and antenna anti-ice switch. The anti-icing valves close automatically on the ground and can only be opened by moving the switch to the test position. A caution note here: serious damage can occur if the wing anti-ice valves are open for more than a few seconds during ground operation. If the airplane is on the ground and the wing anti-ice valve is open, the wing anti-ice disagree light will be on with the switch on or off. In the air, the disagree light warns that the valve does not agree with switch position. The air conditioning system begins with the pack flow indicators, which indicate the flow through each pack, as well as the trim airflow in systems 1 and 3. The pack switches in the pack off position disarm the pack off lights and close the corresponding flow control valves, shutting off pneumatic supply to the packs. In addition, shutting off pack 1 and 3 also shuts off the trim air supply. The auto position of the pack switch permits automatic control of the pack temperature valve. In the auto mode, the output temperature of the pack is controlled by the coldest air demanded by either the cockpit or galley for number 1 pack, or the coldest demand of the 3 passenger compartments for packs 2 and 3. The manual position of the switch provides direct control of the pack temperature valve. The pack off light is armed when the pack switch is out of the off position and comes on to indicate that the pack is shut down, which could be due to high temperature or loss of pneumatic supply pressure. To the right of the pack switches are 3 indicators which monitor internal conditions in the pack selected by the switch to their right. The turbine inlet temperature indicator indicates the internal temperature of the pack. The pack temperature valve position indicator indicates the position of the valve which regulates the amount of air flowing through the air cycle machine and, therefore, regulates the temperature of the pack discharge air. In the cold position, all of the air flows through the air cycle machine and is cooled. In the full hot position, all of the air would bypass the air cycle machine, so the discharge temperature would be quite hot. The pack cooling door position is also related to the pack temperature valve position, so that with the pack temperature valve in the cold position, the cooling doors are fully open. The pack discharge temperature indicator shows the temperature of the air being delivered by the pack into the manifold. The compartment temperature selectors provide control of the temperature in the associated compartments. The primary control of compartment temperature is by the trim air valve, except when a trim air valve reaches the extreme cold position. The pack temperature valve is then regulated toward cold by this control. To review the air conditioning system a little, you recall that the output of pack 1 is controlled by the coldest air demanded by the cockpit or the galley. The pack would then be putting out the coldest air needed, and the remaining compartment would have to have air a little bit warmer. This would be accomplished by allowing entry of some of the hot trim air. It would therefore be logical to see one of the trim air valves on full cold and the other one far enough open to satisfy the temperature requirements of the compartment which tended to be a little too cool. The same should be true of the passenger compartments. One of them would tend to be the warmest and would control the output of packs 2 and 3 to satisfy its cooling requirements. The other two compartments would use trim air to keep from getting too cold. The trim air valve position indicator would reflect these requirements for each compartment. The cold position indicates that the valve is fully closed, and of course the hot position indicates that the valve is fully open, a condition you should see only very rarely. The trim air switch is normally left in the open position to supply trim air from packs 1 and 3. In the closed position, the valves are closed, so no trim air is available. In this condition, the packs must be regulated to supply the best compromise temperature for all compartments. If an air conditioning duct overheats, the duct avionics compartment overheat light comes on and the trim air is turned off automatically. With the duct overheat, it can be reset when the overheat subsides by moving the switch to off and back to on. If the overheat is in the avionics compartment, the trim air cannot be restored, and you will have to use the trim air inoperative procedure. The 5 duct compartment temperature indicators permit monitoring the compartment temperatures at the top and the supply duct temperatures at the bottom of the indicator. Just above the aft cabin temperature indicator is an avionic flow override normal switch. In normal, cooling air flows through the avionics compartment. In override, the venturi is closed and cooling fans are turned on. Continuing, on the far left side of the center panel is the lav galley vent and cargo compartment heat switch. This switch, when on, provides ventilation for the lavatories and galley and heat for the cargo compartments. Next to the lav galley vent and cargo heat switch is the cargo compartment temperature indicators, which permit monitoring of the cargo compartment temperatures. On airplanes 38 and subsequent, there is an aft cargo temperature selector switch next to the cargo compartment temperature instruments. It automatically controls the aft cargo temperature as selected when in the auto position. The manual position allows manual control of cargo temperature by driving the associated valve to the desired position. The selector is spring-loaded to stop in manual. The water quantity and pressure indicators monitor the drinking water system. Pressure is supplied primarily by number 3 pneumatics, or if it is not operating, by a separate compressor. On airplanes 38 and subsequent, these indicators are located on the second officer's right-hand panel underneath the flight recorder manual override switch. The oxygen line pressure gauge indicates regulated pressure in the distribution line. The broad white band indicates the normal range for the system when oxygen is not being used. The narrow white band is the acceptable pressure range when oxygen is being used under maximum flow conditions. No electrical power is required for this gauge. The oxygen quantity gauge is like the ones on other aircraft. A full bottle indicates about 1850 psi at 70 degrees, and minimum is 1650 at 70 degrees. varying 3 psi per degree Fahrenheit. A fully charged system will supply 5 persons under maximum demand conditions for approximately 1 hour and under normal demand for 3 hours. The pointer moves to 0 if electrical power is lost. The red-guarded oxygen mask switch is used to eject the passenger oxygen masks. In the normal position, the oxygen masks will eject automatically at a cabin altitude of 14,000 feet. On airplanes 38 and subsequent, the center and aft cargo compartment have a fire detection and protection system. The controls for these systems are located at the top left of the center panel. From left to right is the agent arm switch, which arms the fire control system for the center and aft cargo compartments. It also shuts off ventilation to these compartments. Next is the cargo fire switch. In test, it tests the smoke and heat detectors in the cargo compartments. All the detectors, master warning, and cargo fire lights should come on when the test is made. In arm position, it arms the fire detection system. The aft cargo vent switch provides ventilation to the aft cargo compartment when the lav galley vent and heat switch is on. The off position shuts off the ventilation system. Continuing with the fire, smoke, and heat detector lights, which indicate smoke in the center aft cargo compartment or an overheat condition in a cargo compartment exhaust vent. To the left is the agent discharge switch, which is self-explanatory. The agent arm switch must be in arm position for the cylinders to discharge. The last switch in this system is the agent discharge test. In test, it verifies continuity of the lower cargo compartment fire extinguisher discharge cartridge. The agent 1 and 2 low lights should come on when positioned to test. On the pressurization panel, with the mode selector switch in auto, the only settings the second officer needs to make are the destination, field elevation, and barometric pressure. The pressurization schedule of airplane cabin altitude is placarded on the panel. The schedule calls for a sea-level cabin up to 13,000 feet, with the cabin climbing as the airplane climbs above that to 1,000 feet at flight level 190, and so on up to 7,500 feet at just over flight level 410. As power is applied for takeoff, the cabin starts to pressurize so as to hold the departure field elevation. The cabin stays at this level until the airplane has climbed 5,000 feet. At this time, the cabin goes slowly up or down toward destination field elevation. If departure and destination are at approximately the same elevation, the cabin levels at destination elevation until the automatic schedule is reached, and then climbs on schedule. If, at 5,000 feet above departure elevation, the cabin is above 2,700 feet and descending, as on a Denver to sea level flight, it will level at 2,700 feet until the schedule is reached. If at 5,000 feet above departure elevation, the cabin is below 4,500 feet and climbing, as on a flight from sea level to Denver, it will level at 4,500 feet until the schedule is reached. Once the schedule is reached, it will climb and cruise on schedule until the aircraft descends 1,000 feet. At this time, the cabin descends as the aircraft descends to slightly below destination elevation at 300 to 500 feet per minute and depressurizes at touchdown. In the semi-auto mode, the cabin altitude for cruise and landing is selected on the altitude set scale by referring to the altitude schedule placard. Cabin altitude rate of change is controlled by moving the rate limit selector. The barometric pressure set scale is for destination only and need not be adjusted until destination weather is received. The rate limit selector may be used with limited effectiveness to vary the rate of change when in the auto mode and is normally left on the index mark. In the semi-auto mode, the rate limit knob provides a variable cabin rate. When operating in the semi-auto mode, the blue semi-auto on light will be on. On the standby control panel, the cabin altitude rate control knob is pulled out to initiate standby operation and rotated up or down to control the cabin altitude rate to achieve the desired altitude. The rate control is detented at 0. If used, it must be returned to 0 before it can be pushed in to return to automatic. When the control knob is pulled out, cabin altitude remains steady until the knob is rotated to attain a rate of change. The blue standby on light comes on. The standby system can be tested on the ground by pulling out on the control knob, pushing in on the blue light, and rotating the control knob down and then up. Outflow valve motion can be monitored on the outflow valve position indicator during the test. When operating in auto, semi-auto, or standby, the airplane is automatically depressurized on ground contact. The standby test switch bypasses the strut switch and is a means of operating the outflow valve electrically on the ground. The altitude schedule placard shows cabin altitude versus airplane altitude on the automatic schedule and at maximum differential pressure, which might be used in the standby or manual modes. The cabin altitude warning horn button is used to silence the warning horn, which comes on if the cabin exceeds 10,000 feet. In this case, the red cabin altitude warning light and a red summary light on the forward overhead panel would be on until cabin altitude descended below the maximum limit. The red master warning lights would also come on. The cabin pressure relief open light comes on to indicate that cabin pressure exceeds the maximum differential pressure above the white arc on the differential pressure gauge, and that one or more of the 3 cabin pressure relief valves has opened. The cabin rate indicator is conventional in operation. The cabin altitude and differential pressure indicator reads altitude on the outer scale and differential pressure on the inner scale. The barometric scale is on the upper left and is adjusted with the baro knob. The engine vibration analyzer system has been deactivated on United Airplanes. Just above the annunciator light test panel are 3 reverser valve open lights to monitor engine reverse operation. Above these are the forward, center, and aft A and B cargo door open lights and test switch. The lights should all come on in test and go out when the switch is released. The A lights test the door closed and locked integrity and the emergency call system. The B lights test the proximity switches and unlocked sensors. A call switch is provided in each cargo compartment in case someone is locked in. When pressed, it lights the A light for that door. The test is performed just prior to engine start. The oil quantity indicators have bugs which may be set after the engines are running to signify any change in oil quantity. You'll notice blue dots on some of the indicators. They are for maintenance use with built-in test equipment. On the engine oil temperature indicator, it is worthwhile to remember that it is permissible to operate with the oil temperature in the yellow range for a maximum of 15 minutes. Minimum oil pressure is the low red line, 10 psi at idle RPM. Oil pressure should be 20 psi at 80%, 25 psi at 90%, and 30 psi at 100%. And should be at 10 psi by the time the engine stabilizes in idle after engine start. The maintenance interphone switch allows the flight crew to communicate with any of the maintenance interphone jacks throughout the airplane using the PA handset. The flight recorder switch is turned to override to enter trip information during pre-flight and is then left in normal. The flight recorder turns on automatically when the park brake is released with any engine running. When the test button is pushed, 6 number 8 digits appear in the ident and value indicators, and the flight recorder off light goes out. The flight recorder switch is turned to override, and trip information is then entered by first pushing the appropriate key to identify the information to be encoded, and then entering the value numbers. If the correct information appears in the annunciator, Pushing the Enter button will put the information on the tape. If an error is made prior to entering, pushing the Clear button will remove the information from the annunciator. Trip, date, and leg are the only parameters entered, and each must have 5 digits to be valid, such as 07011 for July 1st, 1981. The Event button is used to mark the tape to identify a special event. On the annunciator panel, most of the lights are self-explanatory, but there are a couple that are worth reviewing. The 2 blue lights on the center row are labeled Elevator Field Channel in Op and Flap Limit Channel in Op. The elevator control feel is adjusted to airspeed so that control pressures will vary normally throughout the speed range. There are 2 channels for this control, and if one or both fail, this light will come on. There is a related light on the forward panel labeled Select Elevator Field Manual, which comes on only if both channels have failed. So, if the blue light comes on, check the overhead panel to see if the amber light is on. If it isn't, it means that only one channel has failed and no action is required except a logbook entry. The same basic idea is true for the flap limit system, which prevents the flaps from extending past 22 if the speed is too fast. One channel only would turn on only the blue information light. With 2 channels failed, the blue light and the amber light on the overhead panel, labeled Select Flap Limit Override, would both be on, and it would be necessary to move the flap limit override selector to 1 or 2 and observe flap limiting speeds. One other area should finish the discussion of the second officer's panel. The fire detection system consists of 2 loops around each engine and the APU. With the loop selector switches in both their normal position, both loops must be activated to get a fire signal. If either loop is inoperative, the switch may be moved to select the good loop, which deactivates the other loop and allows the single loop selector to provide normal fire detection. The same logic applies to the system test. With the selector switches in both test switches must be held in the test position for a detection system test. In addition to the loop lights coming on during the test, the APU fire light and the master warning light on the second officer's panel will come on, and, up forward, you will get lights in 3 fire handles, 3 fuel levers, the APU fire summary light on the overhead panel, both master warning lights on the glare shield, and the engine fire warning light on the captain's side of the glare shield. There will also be a fire bell which can be canceled by pressing the engine fire warning light or by pulling down the engine fire handles. This completes the review of the second officer's panel. Please fast forward the tape to the end for the next user. This review tape is designed to be used with the panel fold-out from your flight manual. The tape is based on information available as of January 1981 and is to be used for training purposes only, as it may not be current. In front of each pilot, just under the glare shield, is an engine fail light. These lights are armed on the ground only whenever any engine N1 indicator exceeds 85% in forward thrust. When armed, both lights come on steady whenever any engine N1 RPM varies 10% or more from that of any other engine. They would be on during a takeoff run made with an inoperative N1 indicator. If the lights are on during takeoff, they will go off at liftoff. Just inboard of these lights are master warning and caution lights, and, on the captain's side only, an engine fire warning light. The red master warning lights inform the pilots that a red warning light is on at the second officer's station. A red summary light on the overhead annunciator panel will identify the system involved. The amber master caution lights monitor certain amber caution lights on the second officer's panel and the forward overhead panel. 4 amber Q lights on the overhead annunciator panel identify systems which may be involved. The master warning and caution lights, as well as the Q lights, may be extinguished and reset for subsequent indications by pushing the appropriate light. Red summary lights remain on as long as the condition persists. The engine fire light comes on with an engine fire warning. It also may be pushed to reset, and this will silence the aural fire warning as well. A floodlight control knob for the glare shield is just to the right of the captain's master warning light. The flight director switches are located at the ends of the panel. When on, commands from the respective flight directors are displayed in the related attitude indicator. Normally, the number 1 system is displayed on the captain's indicator and the number 2 system on the first officer's. There is a flight director command switch on the overhead panel, which permits selection of either system to be displayed on both attitude indicators. An amber FD light on each indicator will be on whenever this is the case. When a flight director is turned on, it engages into its basic modes of heading hold and altitude hold, or vertical speed, unless an autopilot has been engaged, in which case it engages in the mode currently being used by the autopilot. The back course mode selector provides directional flight director steering commands for capture and tracking of a localizer back course. This mode will not engage if either autopilot is in command, but CWS may be used. Using the flight director back course mode retracts the glide slope indicators from view. When this mode is selected, the arm annunciator shows back course. Back course capture and track will enunciate at the appropriate times. Also, if back course is selected by pushing the captain's back course switch, the GPWS glide slope warning is inhibited. To select the turbulence mode, an autopilot must be on in either command or CWS. When either turbulence button is pushed, a number of things happen. If an autopilot is engaged in command, it reverts to CWS, and its red warning lights come on flashing. Turbulence is displayed in the pitch annunciator, and all other mode annunciators go blank. Flight director steer and pitch commands are removed from view. Automatic pitch trim is deactivated. The auto throttle disengages, and the red auto throttle warning lights flash. The fast-slow indicators continue to display any deviation between selected and actual airspeed. The autopilot holds a level attitude through the turbulent area. Control wheel steering is available with damped elevator response as necessary. To disengage the turbulence mode, re-engage command, turn off the autopilot, or select any new flight director pitch mode such as vertical speed. Moving toward the center from either flight director panel is a navigation control panel. The captain's navigation radio supplies information to the captain's instruments, flight director, and autopilot. The first officer supplies the number 2 units. Frequency selected is shown in the digital display window above the frequency selector knob. A course selector knob and course readout window are also provided. The course knob will change course 1 degree at a time, or, if pushed in large increments. At the same time, on the appropriate course indicator, the course bug is repositioned to the selected course. Each system has a DME selector with standby, normal, and override functions. Normal provides a range of 200 nautical miles, and override reaches up to 300 nautical miles. Standby supplies power for warm-up. Mileage of both systems is displayed in both course indicators when in the radio mode of operation. Next is the auto throttle panel. 2 auto throttle systems are installed. When either or both are engaged, the throttles are automatically positioned to maintain the selected speed or the N1 limit. Using both throttles is recommended. The auto throttles engage in the speed mode except during use of the takeoff or go-around modes, in which case they engage directly in the N1 mode. The auto throttle annunciator displays the selected mode. N1 can be selected at any time the autothrottle is in use by pushing the N1 button. To return to the speed mode, pull out on the speed selector knob. Turning the speed knob changes the speed readout 1 knot at a time or in large increments if held in. An orange speed command bug on each airspeed indicator moves to the selected speed. Fast-slow indicators on each attitude indicator show deviation from the selected speed in the speed mode, but are retracted from view during the N1 mode and the retard mode. Next is the heading panel. The heading control knob is in 2 parts. The larger diameter knob at the base is used to set the bank limit from 5 to 25 degrees. The selected limit is effective for both autopilot and flight director when used in heading select, heading hold, VOR, or INS. The small knob labeled H is a 4-position heading selector knob and is spring-loaded to a position that provides heading select adjustment in 1-degree increments. The first push-in, detent, provides large heading changes. The second push-in detent is momentary and engages the heading hold mode of operation, canceling any other engaged or armed steer modes. Pulling this knob out momentarily engages the heading select mode, referencing the flight guidance system to the selected heading. A triangular bug on each course indicator will move to the heading which is displayed in the readout window above the knob. Just below the knob are 3 buttons. The first one, labeled Nav, arms the flight guidance system for capture of VOR radials, localizer beams, or INS tracks. The ILS button arms for full ILS, including glide slope, and the Land button is used to arm for single or dual auto land. The FMAs, or flight mode annunciators, will display the selected modes. On the next panel is the vertical speed selector. It synchronizes to the airplane's vertical speed with the flight directors and autopilot off, and with it on in all modes except vertical speed and altitude hold. It provides commands to the flight guidance system for altitude hold or for vertical speed as set by moving the wheel. An altitude selector knob, readout window, and reset button are just to the right. The knob has 3 positions and is spring-loaded to the center position where fine altitude adjustments may be made. Rapid adjustment is made by pushing in and turning the knob. Pulling out momentarily arms the flight guidance system for capture of the selected altitude. This is called altitude pre-select. Whenever an altitude is selected, regardless of whether it is armed for capture, the altitude alert system is armed. Approximately 750 feet prior to reaching a selected altitude, a steady amber alert light comes on. At about 250 feet above or below, as the altitude is approached, the light goes off. It will subsequently flash, accompanied by an oral signal, if the altitude is deviated from by 250 feet or more. Pushing the reset button turns off the flashing light and cancels the pre-select mode. The 2 autopilot switches have 2 engaged modes, CWS and command. In the CWS position, autopilot is in the manual CWS mode. Automatic pitch trimming is done by the autopilot, and the pilot may also trim without disengaging the autopilot. The autopilot holds any existing attitude between 3 to 30 degrees of bank and -10 to +22 degrees of pitch. Below 3 degrees of bank, the existing heading is maintained. Attitude and heading changes are signaled to the autopilot. The autopilot holds any existing attitude up to 30 degrees of bank and -10 to +22 degrees of pitch with the flight director in use. If the flight directors are off and bank is less than 3 degrees, the existing heading is maintained. Forces applied to the control wheel are signaled to the autopilot and applied to the control surfaces. The bank and pitch limits may be exceeded by maintaining control wheel pressure, but the autopilot will return the airplane to the pitch or bank limit as soon as pressure is relaxed. Manual CWS is not enunciated and does not affect any other enunciations. It may be used in any phase of flight, including takeoff and landing. To select manual CWS, place one autopilot switch to CWS or apply control wheel force with an autopilot in command. The engaged lever will drop to CWS automatically. In this case, the red autopilot warning lights will flash. To engage an autopilot to command, raise the switch to CWS, momentarily relax lifting pressure, and then place it to the command position. In command, the autopilot will control the airplane according to the selected flight guidance modes. Only one autopilot may be engaged in CWS or command at a time, except that in command, after certain conditions have been met, the land button can be pushed, and it is now possible to engage the second autopilot to make a dual automatic landing. The number 1 flight director autopilot is related to the captain's instruments and navigation systems, and number 2 to the first officer's. Yellow quick-release buttons are located on both control wheels and will release either or both autopilot switches to the off position. Operation of any trim control will also release the engaged autopilot from the command position. The IAS button, when pushed, signals the autopilot in command to maintain the existing indicated airspeed with pitch. This feature is locked out whenever the auto throttle is in the speed mode to avoid conflict. When the IAS mode is in use, IAS hold is enunciated in the pitch window. The Mach button works the same way to maintain any existing Mach. It also will enunciate in pitch. The CWS button is used to provide CWS capability in command in certain circumstances without canceling existing or engaged modes. Prior to entering the capture phase of beams, altitudes, or glide paths, and when not in vertical speed or altitude hold, CWS will enunciate in the steer and pitch windows. CWS is available in the same way as if selected with the autopilot engage switch. When used in this manner, the autopilot switch remains in command and armed modes remain armed for capture. If vertical speed or altitude hold modes are in use, CWS enunciates and is available only in steer. Movement of flight controls in the pitch axis would trip the autopilot to CWS. Whenever command CWS is in use and enunciated in either axis, the associated command bars are removed from view. Upon entering the capture phase of beams, altitudes, or glide slopes, the associated command bars return to view, the capture enunciation replaces CWS, and capture begins. In this case, another feature of the command CWS mode is available. It is called supervisory override and, while not enunciated, permits the pilot to use the flight controls to alter the capture path as desired. During supervisory override, the autopilot resists the inputs but will not trip off. As control pressures are relaxed, the capture is resumed. The system cannot go to track as long as pressure is maintained. Any control pressure exerted after track is enunciated will trip the autopilot to CWS. If command CWS has been used during maneuvering for an ILS approach, it remains available after localizer track is enunciated for possible use during glide slope capture without reselecting. Now, let's look at the captain's main instrument panel. The mode test button just above the airspeed indicator, when pushed, tests the flight guidance mode enunciators. In a successful test, the letters TEST appear, one in each window. This button may also be used to restore normal operation to the enunciators if one goes blank or enunciates incorrectly. The autopilot out-of-trim light comes on with an autopilot in use if a sustained out-of-trim condition exists or if there is a malfunction. Next are the auto throttle warning lights, a red and yellow light for each system. The red lights come on flashing in the event of auto throttle disengagement, except when the throttles are moved into reverse thrust during auto land. The appropriate amber light comes on when one of two engaged auto throttles disengages. If the disengage button on either outboard throttle is used to disengage the auto throttles, pushing it a second time is a convenient way to turn off the flashing red light. Above the attitude indicator are the 4 flight mode annunciator windows. The first one is for auto throttle modes. The second displays arm annunciations as well as approach only or single or dual land. Steer modes are shown in the third window and pitch modes in the last one. A list of all the available modes can be found in the training and reference manual. Since the auto throttle and flight guidance systems have numerous modes of operation, the annunciators serve an extremely important function by providing continuous information in plain language to the pilot regarding modes in use and modes armed for subsequent use. Remember that the auto throttles engage into the speed mode unless the N1 button is being held in or the flight guidance system is in the takeoff or go-around modes, in which case the N1 mode will engage and enunciate. In the speed mode of operation, the auto throttles will adjust to maintain the airspeed selected in the auto throttle system panel readout window. However, the throttles will never exceed the N1 limit selected on the thrust computer, nor will they exceed the flap limit speed for the configuration. If a speed less than a safe margin above stall should be selected, the system automatically changes to the alpha speed mode, which is enunciated and maintains a safe speed. The arm enunciator indicates which steer and pitch modes have been pre-selected. A steer and pitch mode may be armed at the same time. As a capture mode engages, the appropriate arm indication disappears. However, the arm window will continue to read approach only, or single land in amber, or dual land in green, as appropriate for the approach in progress. The steer and pitch windows allow you to monitor progress in capture and tracking phases, so that the pilot knows what the command bars or autopilot are referenced to. Incidentally, the enunciators on both pilots' panels will reflect the modes in use by the autopilot. Should the opposite flight director be in conflict in either steer or pitch, the appropriate command bar or bars will be retracted from view. Red autopilot fail lights, number 1 or 2, will come on flashing when the associated autopilot switch drops from command to CWS or to off. Pushing either quick disconnect button or one of the lights will extinguish them. But remember that the quick disconnect switch will also disengage from CWS. The amber fail lights, both 1 or 2, come on only during dual land when both autopilots are engaged and one or both autopilots malfunction. The lights will go off if the fault is corrected or the landing mode is disconnected. They will also go off when the approach continues below 100 feet on the radio altimeter. When an amber light or lights come on during dual land, the system merely reverts to single land and the approach should be continued in the automatic mode. If the red autopilot warning lights and oral warning come on, however, pilot action to take over is required. In this case, both autopilots are off and the pilot must re-engage in autopilot or fly the approach in manual. Now for a look at the instruments on this panel. The clock is electric, as are all of the instruments on the panel. A set knob on the lower left can be pulled out to set the hands. A push button on the lower right resets or starts a sweep second hand. It can also be reset or started by a remote button located on the windowsill light control panel. A red dot appears if power is lost. Setting the hands resets the red warning dot. The red and white barber pole on the Mach airspeed indicator shows the limiting airspeed for the altitude being flown. At sea level, it should indicate 350 knots, increasing to 375 knots from about 10,000 feet to about 25,000 feet, and then decreasing as a function of the Mach limit of 0.88 to 257 knots at 41,000 feet. If this VMO advisory system should fail, it will point to 257 knots, providing a safe limiting reference up to 41,000 feet. The Mach window indicates 0.15 on the ground, and at speeds above 0.15 shows the existing Mach. A flag covers the Mach window whenever the display is invalid or an electrical power failure has occurred. If a failure of the airspeed indicating system occurs, a red flag appears on the right side of the dial. An orange airspeed command bug moves to the reference airspeed set on the autothrottle panel, and white reference bugs on the instrument can be set manually to identify certain airspeeds such as V1. The attitude indicator has an amber reminder light on the upper left corner, which will be on whenever both flight directors are selected to the same computer by the flight director command switch on the overhead panel. A fast-slow indicator is located on the left side of the instrument to show any deviation from the reference speed selected on the autothrottle panel. If the selected speed is above the flap limiting speed or below a safe margin above the stall speed, this indicator will reference automatically to these limiting speeds regardless of what has been set in the autothrottle window. The autothrottle need not be engaged for this feature to work. When the autothrottle is in the N1 mode and neither takeoff nor go-around modes are engaged, the indicator is biased from view. It is also out of view during the retard mode and if a failure occurs. When the takeoff or go-around modes are in use, the indicator is in operation, referenced to V2 plus 10 knots with all engines running, or V2 if an engine has failed, and will show on speed if these speeds are maintained. A test switch on the overhead panel can be selected momentarily to fast or slow to test this system. The indicator displays 1/2 scale in the appropriate direction. A test button on the attitude indicator allows you to test this instrument. When pushed, 3 flags appear and 2 indications associated with each flag also occur. An attitude flag appears and the instrument shows a 10-degree pitch up with a 20-degree right bank. The flight director flag comes into view along with the bank right and fly up steer and pitch command. And the runway flag shows at the bottom as the runway symbol moves to a 100-foot indication and the runway alignment indicator moves to the right wingtip of the airplane symbol. A glide slope pointer is on the right side of the instrument. The runway symbol at the bottom, in addition to showing height above the runway up to 200 feet, also shows raw data localizer information. The glide slope and runway indicators show 1 dot up left and then down right as the ILS is tested. 1 dot is full scale on the runway symbol. During the ILS test, the flight director command bars normally remain centered, as the flight director should be engaged in basic modes at this time. In addition to the attitude, flight director, and runway flags already mentioned, there is a glide slope flag on the right and a speed flag on the left. The rate of turn indicators have been removed. Remember, the runway flag may indicate radio altitude failure or localizer failure, as this indicator presents information from both of these sources. A point to remember: even with multiple flags showing, the attitude information can still be good as long as the attitude flag is out of view. This is the case during use of the emergency power switch. The radio altimeter has a vertical tape display, scaled from 0 to 2,500 feet. The display is blank above 2,500 and is color banded from blue to green to yellow as altitude decreases. The scale also expands as the lower indications are reached. A decision height bug can be positioned on the tape at any desired altitude up to 500 feet by rotating the set test knob at the lower right of the instrument so that the selected height appears in the window to its left. A decision height light is at the top of the instrument and will come on whenever the airplane descends below 2,500 feet or the selected decision height. The light can be turned off in either case by pushing the light. To test the instrument, check the light off, then push the set test knob. The tape should indicate 40 feet and a flag cover the readout. Release the knob and the tape should return to 0. The flag retract from view and the decision height light come on. Set the knob to below 0 or push the light to turn it off. The flag will also appear to indicate failure of the system. The primary altimeters are electrically powered and present corrected altitude from the air data computers. The readout is digital and indicates to the nearest 20 feet. A pointer indicates from 0 to 1,000 feet on the perimeter of the dial. An altitude reference bug can be set to any desired indication on the perimeter scale by the knob on the lower right. On the upper left is the altitude advisory light. It comes on when approaching a selected altitude. If the selected altitude is deviated from, the light will flash until reset or a new altitude is selected. In this case, it is accompanied by an audible tone. When within 250 feet of the selected altitude, the light is off. Failure is indicated by a red off flag in front of the digital readout. The first counter window shows 10,000 foot levels from 10,000 on up, a green field from sea level to 10,000 feet, and a minus sign below sea level. It also can show several fault indications, such as ADC for air data computer, IND for indicator failure, or NI for no input. The marker beacon lights just to the right are pushed to test. At this time, please turn the tape over. This tape is for training purposes only and may not be current. At the ends of the foldout are the weather radar scopes. The DC-10 has two radar transmitter receivers, either of which can be selected by a transfer switch on the radar control panel on the pedestal. Both scopes display the information from the selected transceiver. The controls are conventional except for one on the lower right of the scope. It is labeled CTS and has 4 positions: off, left, ahead, and right. The off position turns the scope off. The set is still on and the other scope can be used. In the left position, the picture moves to the right so that the viewing area is increased to the left. Ahead shows a symmetrical forward sector of approximately 170 degrees, and right increases the area visible to the right by moving the sweep to the left. On overwater airplanes equipped with INS, an INS radio switch is located just to the left of the RMI. This switch determines whether radio or INS information is available to the flight guidance system. A point to remember is that repositioning this switch does not change the engaged mode of either the autopilot or flight director. If it is tracking a VOR when selected to INS, the autopilot continues to track the VOR until the nav button is pushed, at which time it will arm to capture and track the INS course. The captain's RMI receives its magnetic information from the first officer's compass system, and the first officer's RMI repeats from the captain's system. An off flag appears at the top when the information is not reliable. The RMI can present either ADF or VOR bearings depending upon the position of the selector switches for the number 1 or number 2 needles. Remember that there is no number 1 ADF installed, so that selection deactivates number 1 needle. Either needle will move to a horizontal position when selected to VOR if an ILS frequency is tuned in the appropriate VHF radio. A below glide slope push to inhibit switch light is located just below the RMI. The light is amber and comes on accompanied by the words glide slope whenever the airplane deviates more than 1 1/3 dots below the glide slope when below 1,000 feet of radio altitude. The oral warning is at reduced volume above 300 feet radio altitude. Number 1 VHF nav radio must be receiving an ILS frequency with the gear down and flaps in the landing range for this system to be active. The glide slope warning can be inhibited by pushing this light. It is automatically inhibited if the back course mode is selected using the captain's selector. It should be inhibited by the pilot if a non-glide slope approach is to be made without the back course mode engaged. Once the system has been inhibited, descending through 50 feet radio altitude, climbing through 1,000 feet, retracting the landing gear, retracting the flaps, or returning the number 1 VHF nav radio to an ILS frequency will automatically reset it. The course indicator displays radio magnetic information when the radio INS switch is in radio, and INS true information when the switch is placed to INS. We will discuss the instrument first with the switch selected to radio. A small window at the top index reads MAG, and a small window at the 10 o'clock position reads radio. Now, the mileage readouts at the top left and right are from the respective DME. The readout is covered by a flag if information is unreliable or if the DME is in standby. Dashes indicate that the system is searching, and the windows are blank if no computed information is available. A triangular heading bug on both the captain's and the first officer's indicators is set by the selector knob on the heading panel on the glare shield. The captain's course bug is set by the course selector knob on his navigation panel, and the course deviation bar indicates position relative to the selected course. If the navigation information is unusable, the to from indicator windows show striped flags. When an ILS is being received, a yellow and blue flag shows in the from window. A glide slope scale is on the right. The glide slope indicator appears when an ILS frequency is tuned and a usable signal is being received. If the signal is not usable, a flag covers the readout. Glide slope pointer and flag are out of view when not tuned to ILS. A heading flag covers the lubber line when the magnetic information is unusable. When the radio INS switch is set to INS, the two small windows at 12 and 10 o'clock change to true and INS. The mileage readouts now show the distance to the next waypoint for the respective INS. The heading bug now shows the INS actual track being flown. The course bug indicates desired track to the next waypoint, while the two-pointer shows the direction. The course deviation bar is now referenced to the INS track. The vertical speed indicators receive information from the respective central air data computer, number 1 for the captains and number 2 for the first officers. In case of power or information failure, an off flag appears in a window near the top. On the captain's panel, just below the vertical speed, are the two brake system pressure indicators. Brake system number 1 is pressurized from hydraulic system 1, while brake system number 2 is charged by hydraulic system 3. Accumulators and check valves reserve sufficient pressure for several brake applications in case of main hydraulic system failure. Each brake system supplies all wheel brakes and will provide normal stopping distance by itself. Full braking is available as long as either system is in the normal pressure range. Standby flight instruments, which can be used when normal electrical power is not available, are located on the left side of the center instrument panel. The standby attitude indicator is powered from the battery bus and will be available as long as battery voltage lasts. This instrument can be caged by pulling out the caging pitch trim control knob on the lower right. Turning the knob adjusts the position of the airplane symbol to the desired attitude reference. A power off flag appears when power is no longer sufficient or the gyro fails. An aneroid barometer requiring no electrical power is just below. A knob at the lower left sets the altimeter setting in millibars and inches of mercury. Like the primary altimeter, it has a 100-foot pointer. A drum shows a digital readout in thousands of feet. The indications are uncorrected. The bottom instrument in the group is the standby airspeed indicator. It, too, is uncorrected information from the pedostatic input, the same as the standby altimeter. Just inboard of the standby attitude indicator are the test and fail lights for the GPWS, or Ground Proximity Warning System. This system is designed to alert the crew when one of 5 hazardous flight path conditions occur. 1. An excessive descent rate below 2,450 feet on the radio altimeter. 2. Excessive rate of closure with the ground below 1,800 feet of radio altitude. 3. Descent after takeoff or go-around prior to reaching 700 feet above the ground. 4. Radio altitude below 500 feet and landing gear lever not down. And 5. Terrain clearance less than 200 feet radio altitude and flaps not in the landing configuration. This red GPWS push-to-test light comes on, accompanied by the spoken words, "Whoop, whoop, pull up." The light will remain on, and the oral warning will repeat until the hazardous condition no longer exists. The volume is reduced after 3 cycles, but the warning will persist. This portion of the system also utilizes the number 1 CADC, number 1 radio altimeter, landing gear down lever position, and flaps in the landing range. It is inhibited during the number 1 radio altimeter test when the airplane is below 50 feet on the radio altitude or above 2,450 feet of radio altitude. It continuously conducts self-tests, and the amber fail light will come on if the tests are not satisfactory, in which case the system is automatically inhibited. Push the red warning light to test the system. 1 complete cycle of the visual and oral warnings will occur at reduced volume. The test will not function between 50 and 2,450 feet on the radio altitude. There is a normal inhibit switch on the overhead panel which can be used to inhibit the system for abnormal approaches, such as no flap. Its use requires a logbook entry. Above the engine instruments on the center panel are reverse indicator lights. The amber reverse unlock light indicates that the reverse mechanism is not locked in either forward or reverse. It will cycle on and off while the mechanism is in transit. The green reverse light indicates that the fan reverser is in the reverse thrust position, permitting the reverse thrust levers to be moved beyond the reverse idle detent to provide reverse thrust. An amber reverser valve open light on the second officer's panel is on whenever the reverse mechanism is in transit. The fan stage is the only part of the engine that reverses. All engine indicators require electrical power for their operation. N1, EGT, and N2 are powered from the left emergency bus, except that on airplanes 38 and subsequent, N1 for engine 2 is on the right emergency bus, and N1 for number 3 is on number 3 AC bus. Fuel flow indicators are powered from their respective AC buses. The N1 indicators are the primary thrust indicators and have limit RPM bugs which are normally set by the thrust computer. If the thrust computer is not operating, the bugs can be set by pulling out and rotating the set knobs on the lower right of the instruments. As the knob is pulled out, a window in the top of the instrument is exposed, providing a digital readout to use in setting the desired limits. The EGT indicator has an amber warning light on its lower right corner, which will come on if the EGT rises into or above the yellow band. Remember, the starting EGT limit is 750 degrees. On the N1, EGT, and N2 indicators are red max pointers, which point to the limit red radials. Should any indication exceed the limit, this pointer is carried to the maximum indication reached and remains there to record the excursion. A reset button is located above and to the right of the engine instruments, which can be pushed to reset all max pointers. N2 RPM is restricted from continuous use between 72 and 76%. All engine instruments on this panel have red off flags in case of failure, except the fuel flow indicators. When failure of these instruments occurs, the digital readouts freeze in position and the pointers drop to 0. At the upper right of the center panel is the N1 thrust computer. There are 5 selector buttons to select the mode of operation. The modes are takeoff, go around, max continuous, climb, and cruise. The selected button is lighted blue. The right window displays total air temperature from the air data computer. The left window shows the computed limit thrust for the selected mode, taking into account TAT, pressure altitude, and engine bleed conditions for air conditioning and wing and engine anti-ice. The N1 indicator limit bugs are automatically positioned to this limit in normal operation. The thrust computer switches to go-around whenever the go-around mode of flight guidance is selected. The system self-tests, and if a failure is detected, a flag covers the readout. A speed brake warning light is located just to the left of the thrust computer. It will flash any time the speed brakes are extended with flaps beyond 3 degrees or if the flap handle is moved past 3 degrees with speed brakes in use. The light is disarmed on the ground. Below the speed brake light is the slat reset light. When the DC-10 is operated below 250 knots with the flaps and slats retracted, a stall warning will cause the stick shaker to activate, the outboard slats to extend, and the reversible motor pump's electric supply valves to open, regardless of switch position. Whenever this happens, the slat reset light will come on. Pushing the light and holding it for about 3 seconds retracts the slats and returns control of the motor pumps to their own switches. If this light is on, the flap slat handle will not retract the outboard slats. Below the thrust computer is the flap slat indicator. 2 slots in the instrument face are provided for tapes which move down to indicate position of the outboard flaps. Left and right pointers, called chevrons, move in sync with the flap selector handle. The left chevron also has an arrow which indicates limiting speed for the selected flap position. No indication of inboard flap position is provided, but a red flag appears on the instrument face accompanied by an amber light on the pilot's annunciator panel if the inboard flaps disagree with one another by 5 degrees or more. The flap selector selects inboard flap position. The inboard flaps, in turn, select the outboards as they extend to the selected position. Slat position is monitored by 3 indicator lights. The lights are off when the slats are retracted. The center disagree light is on when the slats are in transit or their position does not coincide with the selector position. The takeoff light is on when the slats are in the takeoff range, that is, between 0 and 25, and the land light when landing slats are extended, position 35 or more. The surface position indicator continuously shows the position of ailerons, spoilers, elevators, and rudders. Aileron indicators are pointers labeled left and right wing, up or down. Spoiler tapes rise to show displacement of spoilers, whether used as ground spoilers or speed brakes. There is a separate pointer for each rudder, but each aileron and elevator pointer shows the collective position of 2 surfaces. Care should be taken during a flight control check to be sure that both surfaces for the left or right aileron or elevator move as indicated by full displacement of the appropriate indicator. 1/2 scale movement indicates one surface is not responding. The first officer's instrument panel is similar to the captain's panel previously discussed. It does contain one instrument not on the captain's, the true airspeed static air temperature indicator. Each readout window has a red off flag to indicate unreliability. A button below the SAT window can be pushed to provide a total air temperature reading in the event of failure of the TAT indicator on the thrust computer. The last area of discussion is the landing gear control lever and indicator lights. The 3 gear lights are green when the gear is locked down, red when any throttle is closed with the gear not locked down, red when the gear system is not safe, and red when the gear is up, but 1 or more doors are not latched. The lights should be off in climb or cruise. A red and green light on a main gear indicates that a safety lock has been installed by maintenance during work in the area. The gear selector has 3 detented positions, up, down, and neutral. The gear is normally held up by hydraulic pressure, but rests on the gear doors in the event of hydraulic failure. After takeoff, the gear door latches are checked by selecting the neutral position, which is marked by a blue dot. If the gear remains retracted after 5 seconds, the latches are engaged. Speed should be below 230 knots for the test, and overwater flights should not be continued if the test is unsuccessful. The handle must be pulled out in order to raise it. A release button is provided to release the handle for retraction if the normal release fails. There is a test button which turns on the red lights when pushed. An alternate gear extension lever is located in the floor just inboard of the first officer's seat. The nose gear downlock position may be visually checked from the forward end of the lower galley. For each main gear, a mechanical indicator protrudes above the upper wing surface when the gear is locked down. This completes the forward panel review. Please fast forward to the end for the next user. This cockpit review tape reviews the instruments and switches on the forward overhead panel and the pedestal. It is based on information available as of January 1981 and is for training purposes only, as it may not be current. You may wish to stop the tape and get the panel fold-out from your flight manual. Starting at the upper left corner of the panel, we see the plastic-guarded hydraulic flight control switches labeled "Do Not Use in Flight," which are for maintenance use. One or more of these switches on limit hydraulic operation, so be sure they are off. The next items are the flap limit override controls. A blue flap limit channel inoperative light on the second officer's panel indicates the failure of at least one channel of the flap limit system, and an amber select flap limit override light on the overhead annunciator panel indicates failure of both flap limit protection channels. This means that the limiter actuator may not retract as speed decreases, and, depending on the speed at which it failed, may prevent flap operation beyond position 22. Moving the switch to override 1 should retract the limiter actuator and turn on the flap limit overridden light. If the flap limit overridden light does not come on, the switch should be placed at override 2, which provides a second motor to ensure limiter actuator retraction. Elevator feel is normally regulated as a function of indicated airspeed to provide realistic elevator forces. Like the flap limit system, there are two channels of elevator feel control for reliability. A blue light on the second officer's panel indicates failure of at least one channel, while an amber light on the overhead annunciator panel indicates failure of both channels, which requires that the elevator feel control switch be moved from the auto to the manual position. The manual slew switch is then used to match the elevator feel reference indicated airspeed to the airplane speed for proper elevator feel. If there is no reaction when the switch is moved to the first dot in either direction, moving the switch to the second dot activates a backup motor. System operation in the automatic mode may be monitored by observing that the pointer follows the indicated airspeed. The elevator feel control switch must be left in the auto position, unless an irregular procedure requires it to be used in manual. The ADG switch is kept in the hydraulic position. With the switch in this position and the ADG deployed, the number 1 auxiliary hydraulic pump is operating. The number 2 aux pump and the motor pumps are deactivated. With the switch placed in the right emergency electric position while the ADG is deployed, the right emergency AC bus, TR number 3, and the right emergency DC bus are powered. Motor pump operation is then restored. The aux pumps, however, are not restored to normal operation until the ADG has been retracted by maintenance. The yaw damp switches provide the control to activate or deactivate the two yaw damp channels on each of the upper and lower rudder segments. When the yaw damp test button is pushed on the ground, the switch illuminates and the test fail and yaw damp inoperative lights come on. A test of all yaw damp channels is activated if the respective switches are on. When the test is complete, the switch light goes off, and if the test was valid, the test fail and yaw damp inoperative lights will also go off. Hydraulic power is required to both rudders for the test to be successful. The rudders move left, right, and back to center during the test. The yaw damp inoperative lights on the overhead annunciator panel will also come on to indicate failure of either or both channels on their respective rudder segments. Refer to the Irregular Procedures section in the handbook if one comes on. Any two yaw dampers operative will be satisfactory for dispatch. In the lower left corner is the aux hydraulic pump switch, which, when held momentarily to the stop or start position, controls both auxiliary hydraulic pumps. When either auxiliary pump is powered, the aux hydraulic pump's on light will be on. The anti-skid switch arms or deactivates the anti-skid system. The test button is operative only when the switch is in arm and turns on all the anti-skid fail lights. If a light does not come on or does not go off when the test button is released, that particular system has malfunctioned. The test will operate with parking brakes on or off. The system is inoperative unless the gear handle is down or the alternate extension lever is full up. On the next panel to the right are two switches, a flight director command switch and an auxiliary gyro switch. On airplanes without INS installed, the aux gyro switch permits the captain or first officer to connect the auxiliary vertical gyro to their attitude indicator in the event of failure of his normal gyro. INS-equipped airplanes have compass and attitude systems stabilized by the inertial platforms, number 1 INS for the captain's instruments and number 2 for the first officers. These airplanes have an auxiliary directional gyro as well as an aux vertical gyro. In the event of INS failure, the aux gyro switch will substitute the aux gyros for the failed INS. For instrument operation, the auxiliary gyros are always running and on standby with the switch in normal. Inoperative lights are provided for the appropriate aux gyros if they should fail. The flight director command selector in the normal position allows the captains and first officers' flight directors to receive command data from their respective computers. With the selector in the both on 1 position, both flight directors are receiving inputs from the computer system 1, and in the both on 2 position, both flight directors are receiving inputs from computer system 2. When the switch is not in the normal position, the FD light on both attitude indicators will be on. Above the aux gyro flight director command switch panel is the ground proximity warning system inhibit switch. This red-guarded switch is safetied in the normal position. When selected to inhibit, all functions of the warning system are inhibited, so its use is restricted to planned, non-routine situations. Awareness of weather and terrain features is important when this switch is used. A logbook entry is required in each case. Above this switch are the captain's compass controls and synchronization indicator. The indicator is aligned with the index when the compass is synchronized. It is possible, however, for it to show aligned when it is 180 degrees out. When selected to the normal slaved position, the gyro-stabilized compass card is magnetically aligned. In DG, it is purely a directional gyro. The set heading knob permits manual alignment as necessary when in the DG mode and can be used in the slaved mode to accelerate alignment. The graduations provide slow and fast rates of heading change during alignment. INS-equipped airplanes have an MSU, or mode selector unit, installed at the top of this section of the panel for the number 1 INS. The switch positions are off, align, nav, and attitude. When placed to align, gyros erect and alignment can proceed from status numbers 9 to 7. Then, after insertion of present position, to lower status numbers. Battery condition is checked and system can shut down automatically if an overheat occurs. In nav, computer changes from align to the nav mode. Nav can be selected from any other mode and will proceed automatically through the standby and align modes, provided that the airplane is parked and present position is inserted. However, going from off to nav prevents the overheat shutdown capability and the battery check. Attitude provides compass stabilization and attitude indicator operation only, with the nav computer shut down. The knob must be pulled out to go from standby to align and from nav to attitude. The ready nav light shows minimum alignment status and will go off when nav is selected. The battery light indicates automatic shutdown when the voltage is low during operation on the battery. At the top of the center panel on INS-equipped airplanes is a dual HF radio control panel. Two frequency windows with frequency selector knobs are provided for the two radios. Each has a mode switch for off, AM, and SSB. The use of SSB, or single sideband, is recommended over AM. The mode selector incorporates a sensitivity knob to adjust for best reception. Both receivers function continuously, but only one transmitter can be selected at a time with the selector switch. Remember, tuning in a frequency tunes the receiver only. The transmitter and the antenna coupler must be tuned by keying a mic momentarily. When transmitter tuning is complete, the tune indicator changes from white to black. A tune indicator is located just outboard of the mode selector for each set. Fuel vapor vent switches are for maintenance use and are spring-loaded off. The engine ignition panel is next. The ignition selector switch in the off position de-energizes engine ignition and prevents normal starter valve operation, except for the override and air start switch. In the Start A or Start B position, the engine start switches are armed, and ignition is provided when the engine start switch is pushed and the fuel lever is moved to on. If the APU is running when the switch is moved to either start position, the APU N1 will increase to about 97%. In the continuous A or B position of the ignition selector switch, continuous ignition is provided when the fuel levers are on. The override and air start switch bypasses the engine ignition switch and the fuel lever to provide dual ignition to all engines simultaneously and arms the engine start switches. The starter switches, if armed by the ignition switch or override and air start switch, are magnetically held when pushed in. The associated start valve is opened as indicated by a light in the switch. At about 45% N2 RPM, the switch pops out and the light goes off to indicate that the starter valve is closed. Just below the start switches is the emergency power switch. In its normal off position, the left emergency buses receive power from their normal or alternate sources, and the battery charging system is normal. When moved to the on position, power is supplied from the battery, through the battery direct bus to the left emergency DC bus, and through an inverter to the left emergency AC bus. The battery switch may be on or off. When the emergency power switch is on, the battery cannot be charged. The white emergency power in use light will be on when the switch is on. The emergency light switch in the off position prevents the lights from coming on and connects the battery packs to the continuous charging system when power is available to the airplane. It may be overridden by placing the left forward cabin attendant's emergency light switch on. In the arm position, the emergency lighting system is allowed to come on automatically when normal airplane power is interrupted. Charging of the battery packs is also allowed when power is available. The on position turns on the emergency lights. The emergency light test switch is used to test the emergency light battery packs. When the switch is pushed, all emergency lights come on for testing the condition of the batteries under load. If all battery pack voltages are normal, the emergency light test light will come on. The test is made with the system armed. The disarmed light is on when the emergency light switch is not in the arm position. Avoid frequent testing as it seriously depletes the battery. At the bottom of the center row are the no-smoke and seatbelt switches. The auto position of the no-smoke switch ties the signs to the landing gear. That is, when the gear is down, the signs will be on. With the seatbelt switch in the auto position, the seatbelt signs will come on anytime the gear is down or the flap handle is out of the up position. Regardless of switch position, the signs will be on if the cabin altitude exceeds 10,000 feet. Above the top center of the overhead panel are the three engine fire handles. If a handle light is on, it indicates a fire or overheat has been detected in the associated engine or nacelle. Pulling the fire handle down trips the associated generator and shuts off fuel and hydraulic supply. It also silences the fire bell, if not already silenced. Holding the handle forward and rotating it discharges the agent into the selected engine nacelle, and the agent low light on the side to which the handle was rotated will come on to indicate that the extinguishing agent has discharged. The agent low lights associated with fire handle 2 will also come on if the cylinders are used for an APU fire. To the right of the fire handles are the controls for the evacuation signal system. The command switch is a two-position switch capped in command for normal operation. Lifting the guard and moving the switch down activates the evac system, causing the horn to sound and the evac lights to come on at all the evacuation signal stations, one in the cockpit, one for each door, and one in the galley. The evacuation light comes on and the horn sounds when the command switch is activated or when any main cabin door starts to open in the armed mode. The horn shut-off switch silences the evacuation signal at the individual panel. Just below the speaker is the evac signal switch, which arms or disarms the entire emergency evacuation signal system. The number 2 INS mode selector is at the top of the panel to the left of the evac signal switch when installed. And just below the MSU is the first officer's compass control panel, and below that, the voice recorder. The passenger address panel has a number of call switches, a PA on switch, volume indicator, and a reset switch. With the handset out of the cradle, pushing the PA switch connects it to the PA system. Disconnect by hanging up or pushing the reset switch. Pushing the mechanic switch sounds a horn in the nose wheel well. Pushing a call switch turns on the call light and sounds a chime at the appropriate station. When the cockpit is called from any station, the appropriate switch lights blue and a chime sounds. Now, just below the evac signal arming switch is the radio nav test panel. The number 1 ILS test switch, when moved to the up left position with an ILS frequency tuned, causes the nav and glide slope flags to appear, then disappear on the attitude and course indicators. The rising runway in the captain's attitude indicator moves full scale left, which is 1 dot deviation. The deviation bar on the course indicator moves 1 dot left, and the glide slope deviation indicators on the attitude and course indicators move 1 dot up. Moving the switch to down right causes the opposite indications. The number 2 test switch performs the same function for the first officer's instruments. The VOR DME self-tests are not approved tests, so VOR and DME testing is as stated in the Flight Operations Manual. The marker beacon test button is inoperative. The stall test switch shakes both columns when placed in either the left or right test position. The max speed warning test sounds the clacker that warns of airspeed in excess of the barber pole. This signal also sounds if 260 knots is exceeded with slats extended on some airplanes. The speed control test switch moves the donut on each attitude indicator half scale toward fast and then slow. The windshield anti-ice switches in the normal position control windshield temperature in the normal range under light icing conditions. The high position applies heat at a higher temperature for moderate to heavy icing conditions. There is no restriction on moving the switch from off to normal or high. The test position lights the windshield heat in op light if all circuits are functional. The defog switch will apply heat to the inner layer of the windshields and sliding windows to prevent or remove condensation. The system will de-energize if an overheat occurs. Normally, the defog switch is turned on and the windshield heat is selected to normal. The pitot static heater current meter indicates the electrical current being used by the selected heater position. Turning the pitot heat selector to any position other than off turns on all heaters in flight. The TAT probe is not heated on the ground. A pitot heat in op light will be on when the pitot heat switch is off or when the captains, first officers, aux pitot heaters, or the TAT heater are inoperative, either on the ground or in the air. The three pitot heaters have dual elements, and if the primary element burns out, the other may be selected by a switch under the second officer's panel. Ammeter readings can be used to check the other elements not monitored by the light. In the static position, the static heat cycles on and off. Therefore, part of the time there will be no ammeter reading for these units. The engine anti-ice switches open engine bleed valves to provide hot air to anti-ice the associated engine nose cowl. The blue engine anti-ice switch-on light is on when a switch is on, and an anti-ice disagree light is on when the associated valve position does not agree with switch position. Note: engine number 2 anti-ice switch also turns on the upper VHF antenna anti-ice system. The standby compass light turns on the light in the standby compass. The cockpit door switch releases the cockpit door latch. The door can be opened normally from the cockpit side and from the outside by using a cockpit key. The windshield wiper switches on each side of the panel include park in the off position. The wipers are electrically operated. The rain repellent switches, also on each side of the panel, apply a measured amount of repellent to the associated windshield each time a switch is pushed. The external lights need no explanation, except perhaps to state that there are no time restrictions on any of the lights on the ground or in the air. This completes the overhead panel review, so you may wish to stop the tape and get the pedestal fold-out out of the manual. At the front of the pedestal on overwater airplanes are the two INS CDUs, or Control Display Units. These panels are used to insert present position and waypoints, as well as to read out various items of information as selected by the data selector. Just aft of the CDUs are the communication panels. A row of mic selectors are at the top to connect your mic to the selected transmitter. The center mic selector switch is red. It is pushed in to connect your boom or oxygen mask mic to the PA system. This does not activate the mic, so you must use your control wheel mic switch or the PTT switch to transmit. Another feature on this panel is the PA switch just above the ADF1 switch, which permits monitoring of PA system announcements on the headset or cockpit speakers. The ADF1 switch is inactive as there is no ADF1 in the airplane. The manual trim handles on the left side of the quadrant override the electrical trim systems, providing direct mechanical control to the stabilizer trim control valves. Rate of trim is proportional to handle deflection, and full travel forward or aft provides full trim rate, the same as the control wheel trim switches. Half travel provides half trim rate, the same as the alternate trim switches on the other side of the pedestal. All functions of stabilizer trim are reduced to 1/2 original rate if the indicated airspeed is more than 250 knots. As with the electrical switches, both handles must be moved together to move the stabilizer. The trim indicator just to the right of the manual trim handles indicates the position of the stabilizer. After 1 degree of continuous movement of the stabilizer, a warning horn will sound until movement stops. The green band on the indicator scale is the allowable range for takeoff. With the speed brake handle in the up or armed position on the ground, spoilers are extended when number 1 and 3 or number 2 thrust reverser is used for a rejected takeoff. When armed, prior to landing, with flaps at position 35 or greater, spoilers are extended upon wheel spin-up. Next, we will review the throttles. On the forward side of the number 2 throttle is the takeoff go-around switch. When on the ground with flaps out of the landing range, pushing this switch selects the takeoff mode of the flight director. In flight, with flaps at position 5 or more, the switch selects both the flight directors and/or the autopilots to the go-around mode. If the autothrottle is in use when go-around is selected, the thrust computer changes to the go-around mode and throttles advance to the limit. Autothrottle disconnect switches are located on the outboard sides of throttles 1 and 3. When either one is pushed, the autothrottle disengages. Pushing either switch a second time turns off the flashing red disengage lights. Reverse thrust levers are on the front of the throttles. These levers can be raised when throttles are closed to place the fan stage in reverse thrust. Number 2 will not go beyond idle reverse until the nose wheel strut is compressed. When the autothrottles are used during landing, raising the reverse levers disconnects them automatically. The takeoff warning horn will sound if throttle number 1 or 2 is advanced whenever slats are not in the takeoff range. Flaps are not in the takeoff range. Spoilers are not fully retracted. The stabilizer trim is not set in the green band, and the parking brakes are set. The fuel levers, in addition to controlling the fuel valves, also control normal engine ignition. If the ignition switch is in a start position and the start switch is pushed in, moving the fuel lever to on initiates ignition and opens the fuel valve. With the fuel lever on, moving the ignition switch to continuous provides ignition without the start switch being involved. Moving the fuel lever to off closes the fuel shutoff valve at the engine and de-energizes the starting and continuous ignition circuits, but not the ignition override system. You are undoubtedly thoroughly familiar with normal operation of the flaps and slats, so we'll only bring out a couple of points. First, that the flap handle may be moved to an extend position without moving the slat handle, but the slat handle cannot move without the flap handle. The second point is that there are 4 positions for the slats: retracted, takeoff extend, land extend, and auto extend of the outboard slats in the event of a stall warning below 250 knots. Auto extend causes a red slat reset light to come on the center instrument panel. This light must be pushed to retract the slats from the auto extend position. If the flaps move to a given point and the slats do not assume the proper relative position, the slat disagree light on the flap position indicator will come on. The gear horn off switch will allow you to silence the landing gear warning if it is caused by a throttle retarded with the gear up. If the horn is caused by the flaps extended into the landing range with the gear up, the horn can only be silenced by correcting the situation. The alternate trim switches provide 1/2 the trim rate produced by the wheel trim switches. The flap takeoff selector provides a movable detent for takeoff flap settings. The only other item that hasn't been discussed on this portion of the pedestal is the park brake light, which comes on when the parking brake handle is set to park and the brake valves are set. A light on the overhead annunciator comes on under the same circumstances. Each VHF communications panel can tune 2 frequencies, either of which may be selected for use by the transfer switch. The standby position of the transponder selector applies power to both transponders for warm-up, but inhibits any response to ground control interrogation. When the switch is in the 1 or 2 position, that transponder is able to respond and the other transponder is in standby. The altitude source switch allows you to select the air data computer, which will provide altitude reporting information. The function switch on the radar control panel may differ slightly from what you've been used to, due to the fact that there are 2 radar sets. In the standby position of the function switch, the receiver transmitter selected by the transfer switch is in warm-up and the other one is off. In the normal or contour positions of the selector, the selected receiver transmitter is operational and the other one is in warm-up. Radar number 1 stabilization is through the captain's vertical gyro or the aux vertical gyro as selected by the switch on the overhead panel. Radar number 2 is stabilized through the first officer's position. On INS-equipped airplanes, the appropriate inertial platform provides the stabilization. On the upper right of the control panel, there are two fault lights labeled antenna and RT. The antenna light will come on to indicate a fault in the antenna system. The RT light comes on when the selected receiver transmitter has a fault. Both fault lights come on to indicate a fault in the antenna stabilization circuits. The auto position on the gain control adjusts receiver sensitivity for normal optimum detection of targets. Between maximum and minimum, it permits manual variation of receiver sensitivity. The ADF control panel is much like the ones you've used before, with the possible exception of the dual frequency selection feature. It works just like the VHF communication radios. Automatic fine-tuning is incorporated, so there is no tuning meter. The cell call system is the same as in other airplanes. It may be reset by pushing the switch or keying a microphone for the associated transmitter. The marker sensitivity switch does the same thing as in other airplanes. The light control panel follows the same logic for control shapes as on other panels, but there is a feature worth noting on the center knobs which control the pedestal flood lights. The knobs are concentric, and one controls a fixed flood, while the other is swivel-mounted and can be aimed to provide the second officer with a convenient focused light for checklists which does not interfere with the pilot's vision. On the bottom right is the ACARS control unit, which operates like all others in the United fleet. Aileron and rudder trim knobs manually reposition the associated control valves to a new position as indicated on the adjacent scale. If more than 5 degrees of aileron trim is selected, the spoilers will start to extend. On the rear of the pedestal is a lever for extending the air-driven generator and a telephone handset for the public address and cabin interphone system. This concludes the review of the overhead panel in the pedestal. The DC-10 training section encourages your comments and recommendations for improvements in future revisions of this tape.